Today we're doing 5-4 dividing polynomials day 1 and 2. Your learning goal is for you to be able to divide polynomials using long division and synthetic division. So we're going to start with long division. And before we start, I'm going to review, I know it's been a while, how to divide with a long division. We use this acronym: divide, multiply, subtract or change a sign, and bring down. So first we're going to divide 21 into 67, which goes 3 times. That's the dividing. Then you multiply. 3 times 21 is 63. And then subtract or change the sign. And then that'll leave you with 4. And then you bring down the next number, or next term. And you start all over again. Then you do 21 into 42, which is twice. Then you multiply, so change the sign or subtract. And once you get here, you will get a remainder of 0. So that means that 21 is a factor of 672 as long as you don't get a remainder. Now, we can use that same concept with polynomials. So we're going to divide 2x plus 1 into 6x squared plus 7x. So basically when we do that, I look at the first term and I try to divide 2x into 6x squared, which will be 3x. And then that's my first step. Then I multiply. So you're going to do 3x times 2x, which is 6x squared, and 3x times 1, which is 3x. Then I'm going to change my signs, or subtract both of them. If these don't cancel, you did something wrong. And then you get 7x minus 3x gives you 4x. And then you bring down the next term. And you start all over again. And you're going to divide by dividing 2x plus 1 into 4x plus 2. Basically, you do 2x into 4x, and you get a positive 2. And so multiplying, I'm going to get 2 times 2x, which is 4x. 2 times 1 is 2. Then I change my signs and subtract, and I got a remainder of 0. So 3x plus 2 is a factor, or 2x plus 1 is also a factor of 6x squared plus 7x plus 2. Here's our next example. The polynomial that we're dividing goes under the radical. The polynomial that we're dividing by goes on the outside. So now we're going to divide x plus 5 into 4x squared plus 23x. So I'm going to look at my first term. X into 4x squared would give us 4x. And notice I'm lining it up with the x's. And then you just distribute. So you get 4x squared plus 20x. From here you change your signs. So you're subtracting. 4 minus 4 is gone. 23x minus 20x gives us 3x. Then you bring down the next term. And you start again. X into 3x goes 3 times. Then you distribute. 3 times x is 3x. 3 times 5 is 15. Then I'm going to subtract. So 3 minus 3 is gone. Negative 16 minus 15 is negative 31. When you have a remainder, this is how you write your answer. Like a mixed number. So it'll be 4x plus 3 plus your remainder over your divisor. And since we have a remainder, that means that x plus 5 is not a factor of 4x squared plus 23x minus 16. So anytime you have a remainder, it's not a factor. Okay? So far, the last two examples, we've had all of our terms in descending order. But if you notice on this example, we're missing an x term. So there's a 0x. And here we're missing an x term. So anytime that happens, you're going to put a 0 as your placeholder. So 3x to the 4th minus 4x cubed plus 12x squared plus 0x plus 5. And then my divisor will be x squared plus 0x plus 1. That keeps everything in line. Alright, so we're dividing x squared into 3x to the 4th. That would leave 3x squared. So make sure you line it up with the squares. Then I'm going to distribute to each of these 3 terms. So I get 3x to the 4th plus 0x cubed plus 3x squared. Then I'm going to change or subtract. That's gone. Negative 4x cubed. 12 minus 3 is 9x squared. And then you bring down the next term. And you start over again. X squared into negative 4x cubed would be negative 4x. So distributing, we get negative 4x cubed minus 0x squared minus 4x. And then I'm going to subtract. That's going. That'll give us 9x squared. 0 minus negative 4 would be plus 4x. Then I bring down the next term. X squared into 9x squared gives us positive 9. Then I distribute 9x squared plus 0x plus 9. Then I'm going to subtract. This is gone. And 5 minus 9 is negative 4. Once you get to the point where the degree of the remainder is less than the degree of the divisor, you immediately stop because you can't go anymore. So when you write your answer, it's your quotient plus your remainder over your divisor. And then you're done. Okay, now we're going to learn about the second type of dividing polynomials, which is synthetic division. A lot of students like this because this simplifies the long division process. But this is only for linear expressions. So if you had to divide x cubed minus 14x squared plus 51x minus 54 by x plus 2. X plus 2 is linear, so we can do it. So what you do is, first of all, we're going to use the opposite of positive 2, or whatever that is, and use negative 2 as our divisor. And then we're going to make sure that all your terms here and they're in order, and we're only going to use the coefficients. So we have 1, negative 14, 51, and negative 54. All right. So this process is going to be multiplying and adding. The first thing you do is bring down your first coefficient, and you multiply your divisor. Negative 2 times 1 is negative 2. That number goes right underneath here. And then you add going down. So we're only using multiplying and adding. Negative 4 plus negative 2 is negative 16. Then you multiply by your divisor again. Negative 2 times negative 16 is 32. Then you add going down. You'll get 83. Then you do negative 2 times 83. Negative 166. You add going down. Once you get to the last column, this is your remainder. And then you want to write your coefficients back. But since we divided now, it's not going to be x cubed anymore. So you're going to get 1x squared minus 16x plus 83 plus your remainder over your divisor. And then you're done. And we'll try another one. Okay, here's another division problem. Forgot to write divide. We're going to do synthetic again. Remember, you use the opposite, which would be negative 5, as your divisor. And then we use our coefficients, making sure they're all there in order. So we have 1, 7, negative 38, and negative 240. Remember, the first step is bring your first term down, and you multiply by your divisor. Negative 5 times 1 is a negative 5. Then you add going down. Negative 5 times 2 is negative 10. And then you add going down. Negative 48 times negative 5 is 240. And then you add going down. This is a remainder of 0, which means x plus 5 is a factor. And then don't forget to write your coefficients back. We lost a degree because we divided, so it'll be 1x squared plus 2x minus 48. And that's your answer. Okay, the remainder theorem is a quick way to find the remainder of a polynomial long division problem. And so the way that it works is you're going to still use synthetic, but all we want is the remainder. So you can have a problem like this. And they'll ask you to find P of 3. So when you set it up, look closely. Make sure all your terms are there. If you notice, I'm missing an x to the 4th. I'm also missing an x. So when you write your coefficients, you want to make sure you put those zeros there as placeholders, or you will get the wrong answer. Notice I'm dividing by 3, not the opposite. So my first coefficient is 1, then I got to use 0, then -2, then -1, then 0, then 2. Alright, so I bring my first term down, which is 1. 3 times 1 is 3. And then you add going down. 3 times 3 is 9. Then you add going down. 3 times 7 is 21. Then you add going down. 3 times 20 is 60. Then you add going down. 3 times 60 is 180. And then you add going down. This last number is your remainder. So you write your answer as P of 3 equals 182. That means that when you divide that polynomial by, it'll actually be x minus 3. Your remainder will be 182. Okay, here's one more example of the remainder theorem. Let's do a negative this time. X to the 5th minus 3x to the 4th minus 28x cubed plus 5x plus 20. And we want P of -4. Alright, always check to make sure all your terms are there. Pi, 4, 3. Up, we're missing 0x squared. So my coefficients are 1, -3, -28, 0, 5, and 20. Alright, bring your first coefficient down. -4 times 1 is -4. Then you add going down. -4 times -7 is 28. And then you add going down. -4 times 0 is 0. Then you add going down. -4 times 0 is 0. And then you add going down. -4 times 5 is -20. And you add going down. So your answer would be P of -4 equals 0, because that's your remainder. So that's the remainder theorem. Okay, our last example, I'm going to show you how to use synthetic division to completely factor a polynomial. So let's say this was the polynomial. And they're going to give us one of the factors. So I'm going to set up my synthetic. Remember, my divisor would be the opposite, which would be -3. I'm going to list my coefficients. Make sure nothing's missing. 1, -4, -9, and 36. Bring down my first term, get 1. -3 times 1 is -3. And you add going down. -3 times -7 is 21. And then you add. Make sure I did that right. Okay, I did it right. So that's 12. Then you multiply. And then you add going down. Alright, so I'm going to write this back as a polynomial. Remember, we lose a degree because we divide it. So this would be x squared minus 7x plus 12. So when they say completely factor, they've already given us one of the factors, which was x plus 3. So my other factors will come from factoring this quadratic. 2 factors of 12, they give you negative 7. That would be negative 4 and negative 3. So I'm just going to bring this one down. And this is completely factored. And if they ask you to solve, then you actually set each one equal to 0 and solve for x. And don't forget your y equals. And then you're done.